Water in its liquid form cannot exist on the surface of Mars due to low atmospheric pressure, which is less than 1% that of Earth, except at the lowest of elevations for short periods. The two polar ice caps appear to be made largely of water. The volume of water ice in the South Polar ice cap, if melted, would be enough to cover the entire surface of the planet with a depth of 11 meters, 36 feet. Large quantities of ice are thought to be trapped within the thick cryosphere of Mars. Radar data from Mars Express and the Mars Reconnaissance Orbiter (MRO) show large quantities of ice at both poles and at middle latitudes. The Phoenix lander directly sampled water ice in shallow Martian soil on 31 July 2008. Landforms visible on Mars strongly suggest that liquid water has existed on the planet's surface. Huge linear swaths of scoured ground, known as outflow channels, cut across the surface in about 25 places. These are thought to be a record of erosion caused by the catastrophic release of water from subsurface aquifers, though some of these structures have been hypothesized to result from the action of glaciers or lava. One of the larger examples, Madam Vallis, is 700 kilometers, 430 miles, long, much greater than the Grand Canyon, with a width of 20 kilometers, 12 miles, and a depth of 2 kilometers, 1.2 miles. In places, it is thought to have been carved by flowing water early in Mars history. The youngest of these channels are thought to have formed only a few million years ago. Elsewhere, particularly on the oldest areas of the Martian surface, finer scale, dendritic networks of valleys are spread across significant proportions of the landscape. Features of these valleys and their distribution strongly imply that they were carved by runoff resulting from precipitation in early Mars history. Subsurface water flow and groundwater sapping may play important subsidiary roles in some networks. But precipitation was probably the root cause of the incision in almost all cases. Along crater and canyon walls, there are thousands of features that appear similar to terrestrial gullies. The gullies tend to be in the highlands of the southern hemisphere and to face the equator. All are poleward of 30 degrees latitude. A number of authors have suggested that their formation process involves liquid water, probably from melting ice, although others have argued for formation mechanisms involving carbon dioxide frost or the movement of dry dust. No partially degraded gullies have formed by weathering and no superimposed impact craters have been observed, indicating that these are young features, possibly still active. Other geological features, such as deltas and alluvial fans preserved in craters, are further evidence for warmer, wetter conditions at an interval or intervals in earlier Mars history. Such conditions necessarily require the widespread presence of crater lakes across a large proportion of the surface, for which there is independent mineralogical, sedimentological and geomorphological evidence. Further evidence that liquid water once existed on the surface of Mars comes from the detection of specific minerals such as hematite and goethite, both of which sometimes form in the presence of water.